Hi, in this video I want to show you the main game engine and that thing that creates sprites and moves them around the screen. Okay, so let's begin with our structure called a sprite. Okay, now we had done this in class, and so we had created this enumerated type such that the status of the sprite is either alive or dead. Now I could have other statuses like dying or happy or sad, but in this case this sprite is either alive and will be drawn and move, or dead and will be removed. Okay, so we're going to create the sprite with a struct, and inside this struct are all the elements associated with that sprite. And these are some of the ones we did in class. Where is it on the screen? Now it turns out I've changed it to signed because I'm going to move my sprites around, and if the sprite position becomes negative, that will be off the screen. So I've actually changed the type to be signed. Okay. Now the image, what it looks like on the screen, is a bitmap that we created that shows what it looks like. All right. So what else do we got? Because my sprites may be different sizes and shapes, I'm going to include the width and height inside of my sprite. So I could have different sprites that have different widths and heights. I don't have to hard code its width and height. Okay. What else do I have? Now my sprites are going to move, so I'm going to give them a velocity. In this particular case, it's pixels per frame, but I could use this as a fixed point number and have half or quarter pixels per frame. But in this case, Vx, Vy is going to be like +1 or -1 or 0 to have the sprites either constantly moving or not. Okay, so that is its velocity. Okay? Now, because my sprites can go from alive to dead, I'll need an image, which is a black image of the same size that will cover up its existence. And then, like I said, its status is going to be alive or dead in this parameter called life. Okay. I got one more, and that is as I play my engine, I may or may not need to draw all the sprites. And so I'll have a semaphore which I'll set to true when the sprite needs to be redrawn. And this semaphore will be important in my game engine because I'm going to move the sprite in the background on the interrupt driven, but I'm going to draw it in the foreground in the main program, and you'll see that. All right, what else do we got? I'm going to create a new type, and now I'm going to have up to 18 sprites that can exist on the screen. Okay? Now this is a static allocation, and I can either begin with none of them alive or some of them alive. And so my initialization will be to populate this enemy array of sprites. Now remember, the requirement for the lab is to have at least 3 sprites that do something in your game. Okay? Now, because I have this background-foreground interaction, just like Lab 8, I'm going to create a semaphore called flag, which tells the foreground to redraw the image. And then when my game is over, once all my sprites are dead, my game is over, and I'll have a flag to let me know when the game is over. Okay, what else? All right, so initialization for this example will be dynamic. And so this is the game start. And so I have 18 enemies. 6 of them are going to be initially alive. And so I will populate the array of the position of the enemy. So this is going to place 6 enemies along the top row. Y = 10 is near the top. X is distributed across from left to right. That'll be their initial positions, depending, again, each eye is in a different spot. Okay. I'm going to have them not all move, so these 6 enemies initially are not moving. Okay, that velocities are 0. I'm going to choose the shape. Again, the shape for what it looks like during the game. It's a small enemy 10. What it looks like when it's dead is a black spot of that same size. And these first 6 will be alive. The width is 16 and the height is 10. Now, again, I've in this particular example, all the sprites are the same size, but they don't have to be. I can specify their width and height depending upon the sprite as I got. Okay. And now, because they're new, I'm going to need to draw it. First time I will need to draw it. Now what I'm going to do is to demonstrate movement, I'm going to move some of the sprites. So sprite number 3 is going to move down. Sprite number 5 will move both down and to the right as this thing runs. And then the other 12 sprites I'm going to set up as dead. They won't be written. So that's my init. Okay. Now I'm going to move the sprites. Now this is the important part about the game. I'm going to move it in the background on a 30 hertz interrupt. And so this is my game, that if an enemy is alive, it will need to be drawn. Okay. And if I have at least one enemy alive, then the game will continue. Okay. And then this is my movement. Now, if the enemy hits the bottom, becomes dead. If the enemy for some reason goes up over the top, it'll become dead. If it goes to the left, it'll become dead. That's why I used a signed number here. And if it goes too far to the right, it'll be dead. So this is my bounding box. So if the enemy wishes to jump off the screen, it will make itself dead. Okay? I'll still draw it, but I'll draw it with the dead screen. Okay, so that's the weird ones. Let's do the natural one. This is basically kinematics now. This is a constant velocity, and so I will move each sprite, if it's alive, according to its current velocity in its position. So you could use this engine, if you'd like, for missiles to set up the direction and velocity of your missiles in this way. But these you'll see are the enemy space invaders. All right, so that's what I'm going to do to move it. Again, this is going to be called in the interrupt service routine. Okay, I did make a black box, and so one way to make a black box of 10 by 60 is just to set all the numbers equal to 0. So that's my black enemy. This is my small enemy 10, which is going to be black and white, as you can see here from the device. Okay, so that's my small enemy. This is my black enemy, and those are the two images I'm going to draw on this screen. All right, what's next? All right, so again, the movement occurs in the background. Notice there's no output. There's no output to the liquid crystal display in the interrupt service routine. I'm going to draw my sprites in the foreground in the main program. And so if I need to draw one of my sprites, and if the sprite is alive, I am going to draw my sprite at its current location, X and Y, when its current shape, of its current width and its current height. Okay. Now, as you remember, the images here have one black row at the top, one black row at the bottom, two columns of black on the left and on the right. So if you see this whole column here, if I move it 1 or 2 pixels right or left, and if I move it plus or minus 1 pixel up and down, I don't have to erase where it was. Okay, so my workflow here is I'm going to move it and then draw it, move it and draw it. Now, if the enemy is now dead, okay, I will then replace what it looks like with a black box here of the size I want. And since this is a semaphore, it was set in the interrupt. It's cleared here in the main program. So I'm going to call this in the main program. So again, I said there were 2 threads, the foreground and the background. Let's see them next. Okay. And so this particular thread is just going to be moving it. So my game, this is going to be called at 30 hertz using a timer interrupt. And so there's the semaphore being set, and there's the game movement going on. So it's going to call this function 30 times a second. Okay? So that's my background task, if you would, to move the sprites, set of semaphore that will trigger it being redrawn. Okay? Okay, so now I'm going to fill in the foreground. Okay, I'm going to initialize my game. I'm going to clear the black screen. Now, in this particular demo, I haven't implemented the ship movement yet, but I'm just going to draw them on the bottom statically. And next, I'm going to remember we used timer 0 in the last video to create sound. I'm going to use timer 1 to interrupt 30 times a second. That's 80 million divided by 30. That's going to execute this timer 1 function. And in the interrupt service routine for timer 1, it'll call game task. After I've done, you notice I disabled interrupts, I do all of my initialization, and then when I'm ready to run, I will enable interrupts. And so this is my main loop in the foreground, checking the semaphore. If the semaphore is set, then it will clear the semaphore and draw the game. Again, the game draw, the output to the liquid crystal display, occurs in the main program. And then this thing will run while there's somebody alive. All right, so, all right, okay, that's fine. All right, why? Okay, let's look to the future. When I want to add more features in here, I would add things like checking for the buttons, playing sound. Now again, if you remember, playing sound doesn't actually play the sound, it just starts the sound. I would look at the slide pot. All of those are all things I would do approximately exactly 30 times per second. Okay, enough talking, let's run it. Now, it turns out it's much faster to run it on the real board, and if you're lucky, it'll run on the simulator. In this particular implementation, there's not much going on, so it will run in the simulator. So in this video, I'm going to run it in the simulator. I would encourage you not to debug in the simulator, but you will be able to see how slowly it runs. How many frames per second does it actually draw? And so you can see that this guy went off to the right, ended up in the bushes and killed himself off. This one is this is 30 pixels per second. So if you think about it, this is running about 30 times slower than it would if it were on the real board. All right, let me summarize. The key points of getting a good game is to figure out what you want to do in the background on the timer interrupt. In this case here, I'm going to handle the buttons. If the button is pressed, I'm going to create new sprites. I'm going to play sounds if there's a collision. Okay, the collisions would occur here after I move them. And so I move it. If there is a collision, I will handle it with sound or killing. If I have a slide pot, I will move it to the left or the right. And just like the enemy, if you have your ship, okay, if you have your ship move 1 or 2 pixels to the left or the right, you don't have to erase the ship in its old spot, and that way the will not flicker. Okay, and then if you set a semaphore in the background and then run your foreground thread, your main program, to redraw the screen and do any output to the liquid crystal display that you want. Okay, that's it. Have fun.